The purpose of this video is to explore several ways of calculating a GCF, or greatest common factor. For whatever reason, students often feel much more comfortable multiplying than dividing in arithmetic and in algebra. It's very silly because these are two opposite operations just working forwards and backwards. A concept that is right there in the middle in between the two is the concept of a factor. If students know how to factor larger numbers in arithmetic, it'll be much more helpful to them in their number sense and breaking things down, and it'll help them greatly later on in algebra. What is a factor? In arithmetic terms, it's just another name for a divisor, a quantity that divides evenly into a larger quantity without a remainder. So an example would be 6 is a factor of 12 because 12 divided by 6 has no remainder. The result is just 2, no decimal in between. Some common things that students are asked to do with factors is to create a list of all factors of a given number or to find a greatest common factor between two or more numbers. Before we go forward, it's important for you to have known the rules for divisibility and prime factorization. If you haven't, you can go back and take a look at the videos that I've already created for these topics. Otherwise, some things might move too quickly for you. So the first task we'll go through is finding all factors of the number 24. What I like to do first is to come up with a factor tree and the prime factorization of any of these numbers. So you can see it quickly here breaks down into 2 to the third power times 3. Now, it may seem tedious in this regard, but later on when we get to bigger numbers, we'll want to do this all the time to save ourselves some aggravation. So next, I like to come up with a list of what I call factor pairs for this number. So I start off with 1 in the number itself, so 1 and 24. Then I look at the next smallest prime factor, which is 2. So 2 and what number gives me 24? Well, that's 12. Then the next smallest prime number, which is 3. All right, 3 and 8 give me 24. And then I look at, I don't have any more unique prime numbers, but combination of prime numbers is 2 times 2, which gives me 4. 4 times 6 gives me 24. I look at other combinations. The next smallest number will be 6, but I've already used 6 so that I know I'm done at this point and there are no other factors of 24. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. A second example is the number 45. I'll repeat the same process. I'll do the factor tree and the prime factorization. In this case, I end up with 3 to the second power times 5. And I'll repeat again, I'll look at the list of prime factors first and then break things down into composite numbers second. I start with 1 in the number itself. Then the next smallest prime number is 3. 3 times what gives me 45? Well, I think about it for a second, and that's 15. The next smallest prime number is 5. 5 and what gives me 45? Well, that would be 9. And I can think of other combinations. 3 times 3 gives me 9, which I've already used. 3 times 5 gives me 15. So I know I'm done. I've already used both of those. So all of my factors of 45 are 1, 3, 5, 9, 15, and 45 itself. So next we'll take a look at what it means to be a greatest common factor. The greatest common factor between two or more quantities is the largest whole number that divides evenly into each one of those given quantities. So for the first example, we'll go through and find the GCF between two smaller numbers, 20 and 24. Now for this type of a problem, all you have to do is come up with a list of factors and circle the largest one between the two. So 20 breaks down into 1 and 20, 2 and 10, and then 4 and 5. And 24 we worked through a couple minutes ago, and we found this list 1, 2, 3, 4, 6, 8, 12, and 24. So you just quickly look through the two lists and you find the largest common factor between the two, which in this case is 4. For the second example, we'll look at some larger numbers and work through things this way. Now it would be very tedious to go through and find the list of all of the factors of these two numbers, 350 and 245. So we'll just work with the factor trees, and I'll show you how to break things down based on those. So the factor trees for each, 350 breaks down into 2 times 5 squared times 7 as the prime factorization. And then we have 245 breaks down into 5 multiplied by 7 squared as its prime factorization. So we will use these and a little shortcut in order to determine the greatest common factor between the two numbers. So what you'll notice is that the common factors as prime factors that these two numbers have are 5 and 7. The 245 does not have a 2, so we can't use that again. So what you do is you take the smallest of the two exponents for each number and you combine those, and that'll give you the GCF. So look at 350, the exponent on the 5 there is 2, and 245, the exponent on the 5 is just a 1, so we're going to take the smaller of the two, so 5 to the first power. You look at the same thing for 7. In 350, the exponent for 7 is 1, and for 245, the exponent is 2, so we're going to take the smaller, which is the 7 to the first power. So the combination that works best for us, the GCF, is 5 to the first power and 7 to the first power. Multiply those together and you get a GCF of 35. So for our final example, we'll look at two relatively larger numbers again in 228 and 684. I hope you would agree that coming up with a list of all possible factors of these two numbers would be very long and tedious compared to our earlier examples. So we'll look at the factor tree for each. In the first case, we have 228 breaking down into a prime factorization of 2 squared by 3 by 19. Then 684 breaks down into a little bit longer process, but it is 2 squared multiplied by 3 squared multiplied by 19. So we'll take away the factor tree now that we have things broken down and just look at the prime factorization of each. Now we'll notice that both of these have the same bases, 2, 3, and 19. And we just have to remember to take the smaller power for each and combine those, and that'll give us our prime factorization that works out to be our greatest common factor. So 2 squared is in common for both, and then we have 3 to the first power is the smaller of the two, and then we have 19 as the same for both, so it's an easy choice there. So you could multiply that out, 2 times 2 times 3 times 19, or if you're just simply looking at things carefully, we can realize that this is exactly 228. We didn't change anything at all. So try to look at things a little bit more carefully before you actually multiply things out. So the greatest common factor between these two numbers is actually one of the numbers, 228. I don't think this would have been very easy to find just using the list of factor pairs. So that's it. Hopefully in arithmetic now you can see how breaking things down into factors can make the division process a lot easier. Obviously, in a lot of cases you'll have remainders, but this will help you along the way. This concept will also help you very much when you get into more complicated expressions in algebra and Algebra 1 and Algebra 2. So thank you very much for watching. Hopefully the combination of this, prime factorization, and the divisibility rules have gotten you onto the right path in terms of number sense in algebra. If you'd like to see more videos, please check out my channel and make comments or suggestions for anything else I should do going forward. Thanks again for watching.